Are you able to see my screen?
Yes, Professor.
Okay, thank you. Okay, so we'll go to our next part of statistics, that is the descriptive. So we have connected the dots. So from probability to statistics in terms of random number generation, doing some rank analysis, percentile, and sampling random and systematic. Of course, there are many ways which you can do. So, because Indians have contributed a lot to, especially Indian researchers, statistics, especially to the sampling theory. So, what Excel offers at this point of time is there are other software that can do some. Moving to the descriptive statistics. So, I have from a population, I have sampled now. That's the whole idea. Statistics is for sample. The sampling can be as low as about 10 records, as low as or at something like 1 million records also. So from 1 billion, so we can have 1 million record as a sample. So that is also possible. So when we move to some small data to big data also, the same concepts apply. Only thing the tool changes or the way you have to see it also changes. So nevertheless, sampling is there, will be there. Without sample, not do it, anything. So people use it continuously. So whatever I talk today, it will be on the samples only. So the examples which I refer to are also samples. So it is from some population. That's what we tell. Some population is something like, it's not arbitrary. It's the way we hypothecate, do an hypothetical assessment of the situation. Try to go forward. So that's an understanding which we always do. So we have an assessment of this thing and we move that direction. So you have a population, then to sample. So for every number which you collect, you have some kind of probability associated. It would have had that thing. So what you see on the screen is just a sample. So we'll understand what are the descriptive statistics and all. So in a way, I have already mentioned in our probability class, we have some kind of, and we have already solved something like a mean, variance, and standard deviation also. The same thing will be repeated through Excel, but with a very good example and all, because that's what we try to do it. So something like, consider a shopping mall in a city. Suppose that we would like to find the average age of customers visiting the mall. This gives an idea of the potential customer segment it is to be targeted for marketing. Thus, finding out the average age of the customers helps us in understanding the profile of our target customer. So, I need to find the average age of customers in the mall. So, that's what I'm trying to do it. So, that's a giving an understanding like how we. So, we have something like we heard about mean, standard deviation, and the variance here. So, we see that like how to calculate what's the meaning of it and try to get into that. So, mean formula is there. So, medium is the item which divides a distribution into two equal halves. Mode is the most frequent items in the distribution. Standard deviation is the value of deviation of a typical item from the mean of the set of distributions. So each has some formula and all. So we do some kind of, so pivoting in statistics is known as cross tabulation, but that thing we apply a method. So that is what is much important. So it is known as a chi-square test. So whatever we did the pivot tables, of course we get a pivot table also. It is known as cross tabulation. With that thing, how to get an understanding between a variable which is on the row and a column variable. That's the understanding. What is the degree of separation, the degree of togetherness, and all this can all will be understood. So let's dive, not waste time, dive it into our problem. I have data of scores of students in a competitive exam. So So I have an ID, I have the gender, so which degree they are pursuing, whether it is a doctoral degree or whether it's a PG or a undergraduate. So score in the exam is put there. So it might be anything here. So I want to understand some kind of descriptive statistics on this. So this is what everybody does. So as I told you, in formal modeling exercise, we try to do some exploratory data analysis. At that point of time, after you have acquired the data, put it in a format for understanding in the data frame. We try to clean the data, transform the data and all. Then we will have a picture perfect data available to us. On that thing, the first thing which we apply is this descriptive statistics, or we see some kind of box plots and those kind of things also. But this is the first way which we try to approach this. So I have this thing ready. So let's try to explore this thing. So I want to know what is the total number of students available, what is the average score in the exam, and what is the score that divides the scores into two halves. The scores are sorted from highest to lowest. What is the typical variability of the scores in data? This is what I want to understand from this. Also draw a pie chart to indicate the number of respondents. Draw a bar chart to indicate male and female respondents. So when I have some question, so the problem statement is like, I need to find, it has a score of this thing, students in a competition. Yeah? So what I need to do, I pose myself or somebody poses you the question of about 4 different ways in which you have to analyze the data, or you have to give an analysis. So we try to do what is best for this. So we have this thing ready. So I have go to my data analysis tab and I try to do whatever analysis is possible. So whatever the data which you are seeing now on my screen is the data which I showed from that book. So it is done there. The first question is like the count. So it's obtained by using the count function in this thing. So I want to find out. So count E4 to E23 is E24. E4 means like I have to count only which are there in my what you call I leave out the variable name or something like that and count whatever is necessary for us. Score in the exam is what which I need to find out. So if I do that thing, so what I get is some the number. Let us try to do this thing. So for the first question which I need to answer, so this a bit. So on your laptops also, please try to this count of close the bracket. So I've got 20 observations or 20 records here. So that is the count. So the first question is answered with the count command. So solution for the second question is obtained using the descriptive statistics from the dialog box of data analysis. Let us try to find out what is required for our. I should have an input range and those kind of things which I try to put it. So I go to my thing. So I have my data here and go to data analysis. First one is the descriptive statistics. I say OK. So I have to give an input range. So whatever is here, I will try to put that as a range. So labels in the first row. So I have an output range that also try to give it. Let me put this in G1. That should be enough. So it take the summary statistics. So confidence interview, kth largest or something like that. So what all, I always click on a wrong window. Say summary statistics. So that is what is required for us. So we'll try to get the summary statistics printed. So let us go here. I say okay. The thing which will use out. So were you able to get this thing? Are you getting the same answers what I am getting? Please answer. What do you answer? Are we on the right path?
Doing, sir, actually, not completely.
Okay. Borders around this. So apart from the regular things like mean, variance, standard deviation and all, you have something else which are there. So median is the center point of the distribution. So it provides the values to the left side and to the right side of a distribution curve. Standard deviation, which I saw, the way which from the mean, like how it will be differing. So what is that? We will not bother about. So the variation is something like 79 to 87. So we don't see that sample variance, but good to know. Standard deviation is 281 from the average. So average is 1833. So how it differs is that by about 281 points from each one of the distances. So range is the maximum minus minimum. So maximum value minus minimum value. I have sum of all. I have count of it. I have other things like a mode. Mode is not possible because no value is repeated twice. So that's why it doesn't have. It is not displayed there. So I have what is known as a kurtosis skewness. So let's understand what is kurtosis and skewness. How are you? So sharpness of the peak of a frequency distribution. So if I plot anything, so if I use this as a normal distribution, so the peakness, what is the number of the kurtosis? So how sharp it is, what which we say. So usually we should not get something like this, some kind of sharp. Of course, that depends on the data. We cannot do anything like however it is there, we will get that thing. Otherwise, usually we get a bell-shaped curve or a mound. So I'm not a great artist, so this is how we should be able to get it. So whatever it is also something like this, some kind of peakedness. So this is known as the kurtosis. What we see here. So skewness is about 0 point. So what is skewness here? So skewness is the measure of the symmetry of a distribution. So symmetry means like exactly it should look something like this. So as I drew on my graph, so this is some kind of symmetry which you are seeing. If I remove this skewness part, so how symmetrical it is. So like whether I am able to divide the data correctly like this, or you might not get something like, you might get a distribution something like this sometimes, or you might get a distribution something like this. So this is not symmetrical in nature. So as displayed here, the symmetrical value. So this is about the way which you understand skewness. So usually, unless until there are many challenges, you do not bother to really look into this. What matters to is like mean and standard deviation, what which you have to see to answer many questions. That is possible. That is how we get summary statistics of data, whatever we have it. So going forward,
So Professor, kurtosis and skewness we won't be using much, huh? Or
no, we won't be using because usually what happens is in a real life situation, you will have data and usually if it is not normal in nature, we try to convert it into normal in nature. So even though the distribution may not look like a hat-shaped curve, so we convert it using what is known as a standardizing function there. We at most make it a normal curve. So it will be mound shape. So we don't bother about the peakedness and those kind of things. So that will not be there. Unless until it is some kind of engineering experiment or a scientific kind of a thing, where even though transformations doesn't allow us to really alter that kind of a thing, at that point of time, we need to worry about that. But really for business and other kind of standard process and all, we will not really see about kurtosis. Because nowhere you will see that interpretation does, but for sake of completeness, we try to put it.
okay.
Yeah. But it will be there, do not worry about it, but it's based on like there are some kind of peakedness is there, peakedness is, so you should not get like this. So as I click on the graph, we won't get something like this. So we have some names and all attached to it. Okay, the peaked kind of a thing is known as the leptokurtic, mesokurtic. So mesokurtic is what's a normal step. Platykurtic is something like some kind of a tapered thing. In between that thing is what which we try to find out. So these are kind of the people who work exactly in a very scientific way and all. At if the regulatory authorities require some kind of analysis to be done clearly, and then all these things matter. We work in a business situation where at least we don't go for a 95% way of confidence the intervals. So 95% is generally what we mentioned, and we don't really bother about it. But in business, one has to take risk and all. So people just try to ignore and move on because we cannot always be correctly going through what is happening, what is in the mind. Because we have to, because there is a lot of in the process, you might be getting data like in a pipeline. Water is coming in a pipe, you have to analyze, send it. So it's like a chain, value chain. Will not will wait for scientific experiments will have mostly small data sets and all. At that point of time, it matters. So third question is like, it's about ID and degree. So, okay. The formula shown in the formula bar are entered in the column case UG, PG, degree as well. In case UG, it is COUNTIF, UG. Here COUNTIF for each one of the thing also can be done. Okay, let's try to do it. How many undergraduates are there? How many doctorates are there? How many PG students are there in this thing? So let's try to. So I use a command known as, this is just a count command. So this is count doctor. So I use COUNTIF. I put a comma. So I'll say what is that? Sorry, it's not the thing I should count it other is equal to count if P2 to 21. Okay. I don't know what's the wrong thing.
Can you use double quotes for DR?
Okay, let me use a double quote. Yes, there are 4 DRs. Similarly, you can do for PG and UG, you will get a count for that. So that's how you try to find out whatever is the. So this is known as a frequency mainly. So frequency is what which we count. So how many UGs are there is in a set of data, whatever is there, we count it and we try to get the number. So of course we get some numbers for that thing. Okay, I get a number as 8, 8 and 4. That's what is being shown. Of course, so the total is 20 of all the things which we already calculated. Now, I have to select a pie chart. So what I do it, okay, in on that thing also it is done. So if I go by that way also you can do it, or else you can insert a pie chart using the whole set of column also. That also is possible. Just go by that logic, try to do it. So I want to have a pie chart for that. So it comes. Not selected, so it is not good. Third, why is it not doing? Okay, I need to count it, I think. So it should do it, but not sure. As usually it counts. Okay, do it. No problem. So yeah, the
So just a question, like count if, do we also have count ifs?
yes, that's a logic. Count IFS is also there.
Why I asked, then we can use that count ifs and we can get all the 4. Then probably with one single cell we can create a pie chart. Just a thought, sir. Let's try.
Yeah, that's good. But if I do count IFS, so it only counts if whatever is there. Else, where I will put it? Like, is it somewhere? Because I only one cell will be displayed.
Other ones, the false
Yeah.
statement will also come.
Yes.
Yes, I got it.
No, this is a very traditional way, but yeah, you have to count and do it. Logic. So PG. So this is PG. Here, paste here. Okay, DR, PR, and all. So I select this thing. Chart. So color coding is there. Represent what it represents. So that's the data. So this is for something categorically nature. So I have a categorical data. So category is a undergraduate, postgraduate, and doctor is a category. So that's what we try to do it. We try to compartmentalized into different groups here. Whatever is defined based on that, you can get an answer for this. Similarly, male and female also can be done. Same thing has been repeated for male and female. If we calculate and do, we'll try to get a bar chart. Let us try to do a bar chart for that. Even though, as I told you yesterday, so I showed that how people do analysis. So 8 charts helps us to analyze something the author had done here. So people can relate to only 3 or 4 charts. So foremost is the bar chart, and people are accustomed to seeing a line chart, then a what we call a pie chart, and at the most like some variation of it, like bar can be vertical or even horizontal also. So that way people can understand. So these are some stuff, because whatever a newspaper utilizes as some charts in it are some common things people can understand. Even though people are literate enough or knowledgeable enough for other charts also, simply for the sake of question, they might try to confuse. Let's say I cannot understand and all. Everything cannot be spoon fed. So you need to do some kind of charts which have make a change in that kind of way you are trying to analyze. Also, it's possible. So for that thing, you may use it. So it has a whole list of things. Like for example, when I go to insert, so I have what this is the bar chart. So this is the line chart. This is the pie chart. So you have an histogram. So you have a tree map. So you have some things like this. So for our, and one other more important thing is scatter plot. Scatter plot we had tried it. 4 things people are very much adept to understand. At least literate. So somebody should be at the level of graduation or something like that. They will try to understand it. So people who don't understand can't really help. So probably by talk or something like that we have to see. So this is for a literate audience and they can understand this. There are huge variations. So if I charts, if I try to where it is. So got whole of these things. So you can use whatever it is. So got a waterfall chart, funnel chart. So these things also can be used. But the thing is like to which audience you are trying to go and showcase it. That is very much important. So you have to be clever enough to gauge that. Start with basics for anything. Don't worry about what people tell. First and foremost is you are important. You need not worry about what anybody tells. Stick to basics, you come up, you get an answer. That is the thing, policy which you have to follow. Okay, so come here. So I change this thing to B2 to B21. I put male. So change this to okay. Well, so I try to put a bar chart for this. So I make that choice. Come here. Different. So females outnumber male. So this is how we have to start an analysis. So when we go to some kind of a tools where we have a programming capability or something like that, maybe we can mix like a kind of chart, like where we can say that in male and who are doctorates, male and female, those kind of mixing of charts and all can be done. So there are many enough possibilities, but that's for a separate audience. But to understand at a very basic level, kind of understanding we try to bring in our class here. For the fourth question, I think it is trying to answer. What is she trying to see here? Okay, in a line chart, she's trying to see like how many numbers are, but this is a wrong chart. But usually, I don't know like what purpose she has used it. Maybe we can try it for the sake of completion, but that's not the way which we try to do it. I can use that line chart for the distribution of a this thing. Say for example, so if I make a choice of this particular that might be like a distribution of marks if I have to say. So go to insert. So across 20 students, the kind of distribution of marks which I have. So this is line graph. So this is the way which we can, or we can do one kind of a what's the kind of distribution also for this thing. So I do insert, so go to histogram. So it tries to create a bin or something like that. So somewhat it looks like a this thing, but exactly it's not a normal distribution. So can I put a curve for this? Let me try it out. Or I can try a box and whisker plot. So if I see this thing, we can make it out. It's not normally distributed, so it's not smudged in nature. So that's what we try to see this thing. So this is also one way of seeing a distribution. Okay. So in the wrong window. So we try to analyze this kind of a thing based on the questions posed. So it can be anything like, so given a set of data, what's the kind of analysis which we try to bring it? So basic descriptive statistics, we try to do it. So let's move to one more example where I have car plants in different areas of the country. So it's a 2-column data only, but what she has shown is 4-column. I think I have shared you the data here. So I have put in a 2-column data. One is the car plants of Maruti, Mahindra, etc., etc. Area where it is. So what's the kind of analysis she does? Try to do it. So I'm trying to create a cross tabulation. Cross tabulation in statistics. Sorry, pivot table in statistics known as cross tabulation. So all statisticians refer to it as cross tabulation. If somebody says it's a pivot, yes, generally we speak it's a pivot, but it cannot do more than a pivot in a pivot table language. But for statisticians, we have to see like what are the other things which we can see through that thing. So Excel offers some amount of analysis for this. Let's see what best we can do it for this thing. So she also goes by this thing, first trying to do a pivoting thing. No problem. We'll also try to put the answer which we get it. Table range. What came where? So in rows I have column this thing. Columns I have area. Okay, let me try to do it. Okay, and let's say insert test interest, insert a pivot table. Yes, the existing worksheet. Location. Let me try to look it here itself. Okay. So, car plants to roast area to or wrong, am I correct? I am correct. And what's the thing which I have to move? Count of areas. So area, I move to values here. So I have got about 16 records here. Oh, it should be, I have entered, it is wrong. So there's the wrong way. I should be able to get only 3 things. I'm getting the 4 things. So with this change, I change the okay, let me take it. In wrong happened. So I say insert pivot table, listing worksheet. Here in this thing. Area here. Count of yes. So this is the number. So this is the pivot or a cross tabulation, whatever we get this way done. So next, what it is. Okay, I could get the. So we have a cross tabulation indicating the frequency of 2 categorical variables, car plants and thing. So when I come to this chi-square test, so I will tell you like how to perform this thing. So here also the cross tabulation aspects there. Same thing they have taken. So car sales in 3 regions. So region 1, region 2, region 3, 4 and all is there. Need to do a calculation. So I'll tell you. We apply what is known as a chi-square test to this. So when I get this thing, we do it. So what was I? The descriptive statistics. So I use a pivot table, try to do it. So when I have a pivot table something, I can perform a chi-square test. So the difference between the 2 columns, like the area where it is, so and the car plant. So whether it is logistically justified or not. It's some kind of hypothesis we try to do it, and we try to calculate a chi-square test. For that data, we'll come to that particular expert. Now for this class or the way which I showed, so this should be enough where we are able to get an answer to the problem. So I have created whatever is the cross tabulation. If I have a third column also, this thing pivot table in our Excel class also. Again, we do it, but only thing is like in a statistical language, this is known as cross tabulation. So again, it was shown. We were able to. So there are many examples here. So you can please do it. The only thing is like you have to see like, or if you have your own data or something like that, please try to analyze it, come up with an understanding on what needs to be done and all. So probably you'll have an understanding, much more grip over what needs to be done. So very good examples are given here. On the right way to analyze it and all, you have to pick. So this was the introduction to descriptive statistics. We'll need to move to differential statistics now. Do you have any questions regarding descriptives? Thing you wish to tell? So why we did probability, we attach some probability number. So when I say this thing, this number came because of some probabilistic understanding. Due to some probability. So score is a random variable. So we attach that probability, and whatever analysis somebody does is statistics. So that's what we. So that's a link we have to. So going to modeling and all, you may have got a data frame, everything is there. At that point of time, you try to analyze it. So any questions, doubts? So I don't know, like whether you have done this thing in the past. Sometimes your workspace, anything you have done, was this used before, knowingly, unknowingly, or was there any template provided by your company that you try to do this thing? At least standard deviation and those kinds of things. Some experience, anybody, because that's what matters here. So my thing is a regular affair, like have something, have a data, how to analyze it, connect the dots. That's what I can do. But more meaningful is your examples. Of course, whatever examples we have in there are many things you can follow. But any experience about using the average somewhere in your work? I think there's one or two might have some examples. Have you used this somewhere?
I was trying to use this once, Professor Yatish here.
Yeah, tell me. Yeah.
Yeah, like what I work in right now is a client where they're developing a timesheet application.
Okay.
So we had a lot of timesheet data, different cost centers and status and all. Based on all that, we were trying to get some data. I cannot recall exactly what it is, what the data we are trying to do.
Yes. So now mostly like probably as a value addition, you can use this thing.
Yeah.
So probably, I don't know, probably that project maybe continuing also, or you might get a new project and all. Think of applying like this.
Yeah.
So you speak to your management or your manager or something like that, or a client also. Try to bring these components little bit. So make some understanding from the data, like where you say that how it is differed, why it is differed and all. Just take things like what's the maximum value, what's the minimum value. So what is the average of that thing, and what is the standard deviation or variance also, you can say how distributed is the data. That way you can speak about. So immediately they'll say that they cannot understand things. So make them understand some concept, little bit. Don't get into theory and make them understand meaningfully the way of example. That will serve a good thing. By that way, you will get an, I don't know, like you might have those sort of, I don't know, have some kind of awards. And many companies have some awards and spot awards thing. Probably your way of saying things and all might earn you a spot award. Yeah, good. That was one example. Anybody else? Any example? Anything to which you
We used in the mathematics actually the means in the engineering. After that, we didn't get chance to use because different technology I worked.
Okay, good. Yes, see, many things are there which will be covered as silos. See, we will never know. See, even when I was doing my high school also, we had this line of description. I didn't attach any meaning to it. Just for passing it out, my parents said that you have to do very good in the exam, and so I just passed out. But for that, the real meaning came like when I was attached to. Of course, some people may use it, some people may not use it, and all. Today it's a data world, so make it a point to use. What I always say that. So you have to get accustomed to using these things wherever, because today to answer anything, data is something which save you today. Without data, for any beat anything for that matter, you not have to be a mathematician, statistician, or whatever it is. Any domain you are there, you have data today. If you have data, do some basic analysis and try to get results that will save you. That much please keep in mind. If you use it really, it will be of value. As and when you practice, you bring things and all, that will be great. Of course, have a set procedure or something like that for you to complete. Your manager might have asked something like that. It's all fine. Apart from that thing, what is the thing you can bring that? That will be your some kind of desires which will have it. You can, because data is what which will save you. Is that keep it in. Okay. So when I moved from descriptive and all, so people do ask like a lot about inferential. What matters in statistics? So if you know statistical inference, two aspects like one is like the hypothesis testing. So many tests and all which we're discussing or in today's class and the next classes also. This is what matters a lot. So testing a hypothesis is very much there. Whatever we use it and all is there. Basic like probably from March 2021, my MBA class and all, I had one example. Like at least it started in last of the classes. I never used it, but I just gave an example what could happen. But for my July batch of 2020, what first I started using the example of this inferential to connect the dots. So the lockdown was there. People were trying that. Okay, now that coronavirus is there, so people were trying to find vaccines and all. People said that all people like very fancy things on WhatsApp or Facebook, your news and all, tons of things. People, all gang was given to us. They said that yeah, if you have vaccines, everything is cured and all. That's all fine. But remember one thing. This is the same example which I always give to this thing. And this is best probably this generation or people and all may relate and people have experienced this. So to create any antidote or a medicine for something, you have to create the virus in the lab. If you create a virus in the lab, of course, you have to use any chemical compounds and all which will kill it. So that's what is done. So vaccine is a preventive medicine. So that's what I can say. It is not a medicine after you have got it. So let's go to even a bit deviation from this thing. So for example, if you have fever, you take Dolo or Crocin or whatever it is. To get the Crocin to market or Dolo to market for human consumption, it requires 20 years. So what matters here is like that samples. So how people collect samples, like so how is statistics used in that business? You use it like I'm trying to get the contextual thing like why even small samples matter. Why we should know this thing. 20 long years you have a preclinical trial, clinical trial 1, clinical trial 2, clinical trial 3. Then you have the market testing. So it passes through 5. So almost about 20 years it requires for a crocin kind of a drug to come to market. So how people could do it? Of course, today using data science, statistics, the computational power and all. So to get the sample, so for example, if somebody is being treated with a drug or something like that, they require samples. So who is the person who will come for testing? So they choose like 10 people who are healthy individuals will be given who have some disease or something like that. They are injected this medicine. Some healthy individuals also are given some medicine. So all I have a data is like injected before, injected after. So what are the parameters say doctors or the researchers find out? Maybe there be their sugar or their fever. All these things are monitored parameters and all. So to compare the average mean of somebody who took the medicine before getting it and after getting it, how he was treated and all. That kind of comparisons is what people start. So that's a thing which regard to clinical trials, and you people can really relate. Probably all have got the vaccination and all. So how did they do it? Like within 6 months and all. 6 months is not the time we'll copy. But today, to do like why we studied simulation, as I told you, consider that as a greenfield project, for example. So I have all I get is a sample for about 10 people. They have not done 10 people like across India. They have taken different samples of people and it was tested there. So two people came up with that vaccine. One was that Covaxin and one was the COVID shield. So Covaxin, like there, India means like it's a diverse set of population. Let's leave out culture and all. So in terms of biological structures or biological I don't know how you say the composition of an individual, we all differ. South differs from the north, east differs from the west. That's all one thing. Like in terms of like people in Maharashtra differ from people in Gujarat. So this kind of thing. So this drug or this vaccine which was tested and all, so they will compare. For example, like something. It's not Mumbai only is taken as a parameter. Somewhere in Maharashtra they take a small town where this will be tested because the lot of healthy individuals are not in cities, so villages and very raw places and all, where you get some kind of healthy people. So you pick up some from there. So they are given a drug. So if they have contacted this, they will also be given a drug and all. So compare this thing, this kind of t-test. So small sample student t-test used. And if it's a marketing kind of a thing, for example, so before yesterday I was talking about iPhone example and stuff. So what is the basic design of a thing like example? So iPhone may not have the same iPhone 14, iPhone 15 and all might not have the design which we see in the market. It would have had many versions of a design. For example, physical design I'm talking about. So how it is compared? Like for example, somebody creates that thing and it go through people who will test it in terms of like form factors and all those kind of things. So 1,000 people in a certain area, it will be tested in 1,000 people in different areas. What's the opinion they give about? So this is like two columns of data or one column of data will be there. That's the comparison they have to get. That's where we try to it. So it's clinical trial, medical research also will use it, marketing also, sales also, whatever it is, name it, we will use it. So the comparison kind of is different nature. That's what we try to do. And it is very, very important. When I say 20 years or something like that, Indian Medical Authority, the Food and Drug Administration of America and something like that, the submission of the test, whatever happens, is through a software. Earlier on, all like about 20 years back or something like that, people used to use the software known as SAS, SPS and all. Afterwards, it became open source and all. So people accepted our software. So Excel also is. So people who submit that kind of a submission in terms of what are the sample used, how the t-test was conducted, on what software and all, which is given to the authorities. Authorities also on their computer, they'll take the samples, use Excel and calculate it. Whether the same answer comes and all is compared. So day in, day out, they try to use this kind of a thing. So it's not that thing you learn for some business course or something like that you forgot. So people say that, oh, I didn't choose mathematics because it was tough for me. I chose. No, that's not the answer which you have to use it. When it is also we use it. Medicine people are told that no, I didn't like mathematics. I chose biology, went on to become a doctor. That's not the answer. They are also supposed to know about this. Very much important because the decision making process is through statistics. So that's what we try to understand why this is important through an example. And the way we interpret results is very much important. And we learned about inequalities, if you remember in our earlier classes, less than or equal to, greater than or equal to, equal to, less than, greater than. So that plays a major role setting up our hypothesis also. That's what we try to understand. So that's how inferential is very, very important. We have the knowledge of these things in a particular way till we come about modeling. Because when I show regression, I show a mix of everything what I have done today. In our statistics course. So that's where you see that, oh yes, I have to learn this to answer that kind of problem. Nothing is magic in life. Somebody sells you an idea of black box. No, it will solve all the world's problem. Sorry, do not believe. You should do step by step only. Then only we come to know about. Now let's try to understand this thing too. So this is known as a small samples students t-test. So it's some name given as student t-test. So that's what we'll try to use it. So let us take an example of a manufacturer of nuts and bolts. Suppose that he wants to know whether the bolts he has manufactured is of required size or not. How can we accomplish that? By taking a sample of bolts he has manufactured and comparing the characteristics to the required characteristics is the problem. So that's how we try to build up an example. So I think let me close this thing. This also let me close. Some chapter 6. So I'll take 6.1. So nature you understand. Give an example, some manufacturing also. We'll take something like from a scenario is different here. Let's try to see what is there. A population is the entire universe of items under study, and a sample is a small set of the items under study used to draw. So the vaccine for the coronavirus was tested on some samples only. It was not tested on 140 crore people of India, 40 crores plus of India. Maybe it was tested then less than 1 crore of people, but it was given to all 140 crore people. I don't know who got the second vaccine. That's a doubtful thing. At least as of the government figures, all have got their first doses perfectly right. So that's what we can assume. Everything has gone out correctly. But for a 150, 140 crore, that is the population of India, less than 1 crore as a sample was tested and it was found the efficacy was very good, and it was suggested, medical authorities told that, look, boss, it is all good, government, you start giving it. So Covaxin and COVID shield were produced in mass quantities and all, it was exported to friendly nations and all that magic, political tamasha also all went across fine, but that was the thing. So please understand, to answer a question, to solve the problem of 140 crores plus people, less than 1 crore people were vaccines were tested, and the same t-test kind of a thing would have been applied, because that has to be submitted to the regulator authority. That you please keep in mind. So this is how the real application has happened. As I told you, from the July batch onwards and all, I use examples so people can relate things very quickly. So actual study is done only on a sample, which is the feasible option with lesser cost and lesser time. Okay, and inferences are drawn about the population parameters. Less than 1 crore only would have been tested vaccines, both companies, but it is true for 140 crore plus people of the Indian population. So, do you people have anything to comment about it? Do you understand what I'm telling? Like, yeah, anything. Probably, I think something should come to your mind which you'd like to talk about. Hope you understand what I'm telling. Like, because I particularly taken this example of vaccine. So people don't know, like, and at that point of time, they have used this thing. So T test was used. Yes. Yes, somebody was trying to.
Yeah, got it. This when sampling here.
Okay, I didn't hear the survey. I think your voice got lost.
No. It's a Wi-Fi network is little low, and one LAN sometime connecting in this Zoom, sometime connecting to my office. So it's swapping in between.
Okay. Okay.
Okay, I told we got it the sample that many people we are taking sample and experiment on this way. The same sampling we learned in the digital one. My electronics we read the sampling. So that is the digital device sampling there.
Yes.
Mean and sampling we learned.
Yes.
I don't know much. I forgot everything, but it is there in mean, sampling, deviation. So how the heartbeat pulse square and the pulse is now up and down 0, 1. That is the mean. It was there. So digitally.
Good connecting the dots. So it can be to anything, but I gave a live example because which we have all faced. So what was used? Probably will not know that the T test was used there. Yes, definitely. Whichever part of India, all samples collected by this vaccine producing companies have used this thing, and they have all submitted it to the regulatory authorities. They would say, okay, yes, fine, you can go ahead. Then Government of India, Ministry of Health will say, okay, we'll start the vaccination drive. So everybody will be given vaccination. That's what it does. So because the study of the entire population is rarely done because of the cost and time constraints. So a student T test can be used whether a sample belongs to a population by comparing the sample mean with the population mean. As a one sample test. Two samples belong to the same population by comparing the two sample means. So we have a two sample test. So student T is a small sample test. It is used when the sample size is less than 30 and population standard deviation is unknown. So in this exercise, we are using a two sample test. The one sample test is left to the reader as an example. That's fine. So you can do it. So let's try to do this two sample test. So a teacher claims that people who work for only 5 hours per week will be able to score significantly lower than people who work 10 hours per week on a quantitative abilities test. He brings 20 people and randomly assigns them to one of two groups. In one group, he has participants who work for 10 hours, and in another group, he has participants who work for 5 hours. He conducts the test for all participants. Scores on the test range for 1 to 10, with higher scores representing better performance. So test if there is any significance difference between those who work for 5 hours per week versus those who work for 10 hours per week based on the test performance. Project live or for this academic project or something like that, this thing matters. You have to set this hypothesis based on this way. Have a problem statement. Based on that thing, you have to set a hypothesis. That's what the author does it. So have data here. Group working for 5 hours, group working for 7 hours. So I have got some data with some marks given for each of the cells here. So we frame the null hypothesis H0 and an alternative hypothesis HA or H alpha or whatever, H1 or whatever it is. So population mean for group working 5 hours is mu5. Population mean working for 10 hours is mu10. That's what we try to do it. So we remember I taught you inequalities particularly because of this exercise. So because if we do that thing only, why we studied inequalities in our college days or whatever it is because of this. This is one thing. In many other cases, that's a different. So average of this column. So is it 5? Let us see that thing. She has given that up. So I take an average like okay. Average of okay. So this is for group working for this thing is 5 hours. Okay, sorry. So this is an assumption. For 5 hours for work, that 5 is taken. That's 10 is sorry. So second thing is the alternate is like mu5 or people who work this thing is less than mu10 is a one more alternative hypothesis which we frame. So I am trying to test if there is any significance difference between those who work for 5 hours per week versus those who work for 10 hours per week based on the test performance. So I set my hypothesis null, both means are same. The mean of the first group is less than the second group is what we try to find out. So let's try to find an answer to this. So what is what which we get it. So what we need to do is author finds a descriptive statistics also. Okay, let's also do a descriptive. Why not? Is what completely she takes or okay, for both the things we are getting it. Okay. Let me take this thing. Go to data analysis, descriptive statistics. Okay. B1 change things. The data which I have to take, labels are there, output. We choose something. Choose column here. Summary statistics. Okay. Save. Okay. So for each one of the things, I have the comparison here. So I have a mean for the first column, mean for the second column and other things and all are calculated here. So the first way to go about. So looking at the standard deviation, roughly the ratios are closer to 1, which is between 0.5 and 0.2. Thus we can assume equal variances. So this has an equal variance. So as you have seen on the screen, so standard deviation is here. What is she saying? 1.9 something error. What I got it here? Is 1.2. Where to get an idea of that? Okay, ratios are okay. 1.919 is rounded off to 1, and here also 1.28 can be rounded off to 1. So thus we can assume equal variances. That's fine. Select t-test to sample assuming equal variances option from the data analysis. Then we move to the data analysis, where we have to say that to sample with equal variance, because these two things are somewhat nearer. I see this 1.19 and 1.28. So we assume both things are closer to 1. So variance is same. That's what we said. Because both standard deviation variances are related. So square root of variance is the standard deviation. That's why we get this. So based on, so we have to do this, then come to a conclusion, then select the t-test appropriately here. That we have to keep it in mind. Okay. Yeah. Data, go to data analysis. T-test assuming equal variances, and I say okay. Variable 1 range. So the range which I have, variable 2 range, the range which I have, tables are there. So alpha, so 95% confidence will go about. So that's what I will try to do. Now hypothesis mean difference. Alpha 0.05. Alpha is not taken. P22 output. So I get an answer for second one. Where should I put the output here? Out range. So I try to put that. Fine.
Professor, variable 2 range is not selected properly. One value is missed.
Okay, thanks for that. Okay, that's fine. Okay, let's stop. So this is t-test assuming equal variances because both things are near to 1. If you round off, that's what this highlighted. So from this only we'll come to know, otherwise come to know. Equal variance. And this and things are both related. So we call this as a general variance. What is this? So get a mean, variance, the observations and all. Pooled is like for both these things, how we try to analyze. So what matters is this thing, one tail test, tail test. Let's see that. Interpretation is important. So I get this thing perfectly right. So looking at the less than symbol, the alternative hypothesis, we conclude that it is a left side tail test. Now looking at the p-value for one tail, the value is 1.06. So E minus 0.6. I think in my mathematics class, I have told you that minus 0.6 is 0.12345. Then I have got 106 value coming here. So it is almost the 0, which when rounded off to 3 decimals is 0. So this is equal of this is value of 0 is less than 0.05 or 5%. So definitely, whatever value is less than 0.05, because we have a comparison purposes try to do it. Hence, we reject null hypothesis H0 and accept alternative hypothesis H alpha. Thus, people working for 5 hours a week score significantly lower than people who work for 10 hours. It's our interpretation which we have to do. Let's see. Let's go back here. What's the hypothesis we have framed based on the questions asked by the client or the manager, or the kind of problem which you are trying to solve. So I cannot copy paste. Okay. My hypothesis is H0, both group 5 and group 10 are same. Alternative is mu5 is less than mu10. So probably the first thing doesn't work out for us. That's why we have the second. So that is demonstrated by the example also. So how, for example, for the vaccine submissions and all, they try to do is like, so whatever the sample they try to do in one particular some village or some kind of a small town or wherever it is. So the healthy, before administering of this thing vaccine, how their medical conditions, after administration was there. So this kind of understanding makes of people. On that understanding, we come to a conclusion. So in our case, we reject the mu5 is equal to mu10. We accept the alternative. So that's something which we get because our calculated value of will is 0, which is less than 0.05. So we accept the alternative. So the people working for 5 hours a week scored significantly lower than people who work for 10 hours a week. That's a conclusion. So that is one way which we got an answer. There is one more way also, and that answer is also there. Another method for deducing the inference is looking at the t-stat calculated value. In this thing we got minus 6.83 and the t-critical one-tail value. Here t-stat is this thing and t-critical one-tail is 1.73406. So it is also given here 1.73. Earlier days we used to get some statistical tables and all which we don't use it. So the negative value of t critical is to be considered. Consider figure. So here. So we put a data assuming that this follows a normal distribution. So the acceptance regions are, so that divides this thing is the median. So whereas we have a dark gray color is the acceptance region, rejection region minus 1.73. What is that minus 1.73? So that's the t critical one tail because we have a negative this thing. Because t stat is negative in nature, we consider whatever falls to our left side of the tail here. So this lies to the left of the critical value since it is the rejection region, null hypothesis H0 is rejected. Thus, we arrive at the same conclusion as the above. So, two ways from this data which we can say that the same things works out for us. So, we reject the null hypothesis, accept the alternative. So, that's how we come to. So, for one data of that vaccine test, one city you might get this, another city will throw a different answers for this thing. It's also quite possible. So we make a collective decision. Like for example, say about for 140 crores, we have tested one crore people a sample. Try to give a projection for the 140 crores and all. So it is like take one all the results one above the other. So what scores from that kind of a thing? What the people will take an understanding the medical council. Based on that, they will take a decision about vaccine people. So This is the way which we try to interpret it. So this interpretation is very, very important. So in the above problem, there was a less than sign in alternative hypothesis. So left tail test was used. For a greater than sign, the alternative hypothesis, right tail test should have been used. For a not equal to sign, a two tail test should have been used. Thus, there is significant difference in the scores of groups working for 5 hours and the group working for 10 hours per week. So that's why we accept this thing. So this interpretation, all these things are all fine. Whatever is mentioned is this interpretation is expected of a academically what the student writes for this thing. So in your problem solving in your office and all for problem in question, the data which you have in that and all, if you are using a T sample test, how it will interpret. So hopefully you have understood whatever I was trying to tell. So this is what I had for today.
Professor, just a question. Sorry to interrupt.
Yeah, please.
How is the T critical value taken as negative here? We have got positive value, right?
Yeah, we have got this thing because we have got a less than sign, no? So that's why I have taken that. Because while framing the hypothesis, a less than sign I have taken it.
Okay. Since we are considering it as a left tail test, we are taking it that way.
Yes, definitely. Perfectly. You're 100% right. So that's how we take it. So you have to be very, very careful. That's why the inequalities chapter, of course, I gave a very brief in about 15-20 minutes or half an hour or something like that, or even lesser than that. But this is very much important. How you frame this thing. Probably in your research methodology class, professor might have told or something like that. Some things you will be using like this and all. But for your problem, if you are framing this hypothesis, you have to be very, very careful. I repeatedly say that thing. So it is not magic cannot happen. So any software will not set it for you. Software can only calculate the results based on the way which you have to do. You have to perform this. You have to choose whichever is the equal variance or an unequal variance and try to apply this. Come to so this diagram is by the author itself. Previously, like about 20 years back, and we used tables. Now it is more a software. Depend on this. Two ways you can interpret it. I mean, the completeness of the result is correctly shown. That you have to understand. So, any questions, please? Any other thing? But that's a good observation. Please read between the lines whatever you are trying to solve and try to do it.
Just another question out of this, Professor. Can we consider statistics and analytics as same, like this descriptive statistics and descriptive analytics?
Yeah, analytics is a superset kind of a thing. So you use, as I told you, like I don't know, like whether in this lecture I may not because I concentrate more on the math and stat part of it. When I come to analytics, I always say that it's a mix of history of. So when you see a Venn diagram, so I've got about 5 to 6 circles, and what is the intersection of these 5 to 6 circles is analytics. So you have in analytics, you have statistics, you have mathematics, you have visualization, you have got information theory, you have got artificial intelligence, and what you call, you have got cybernetics, everything there. The cocktail is there, or a mocktail or whatever. That is analytics. This everything used in that thing. One of the things is statistics also, and it is a precursor to analytics. I can say most of the theory and understanding has statistics. But today, what happens is that they say that statistics is difficult. You cannot do this thing. You put it in a software, and no, that's all not. For a real problem solver, you stick to the basics of it and try to. Just for the heck of it, as people say, no, I don't want all those things. Simply give me the result. For them, it's fine. But please, you have to stick. Okay, any question, please? Okay, if I don't have any questions, let me stop here. So meet tomorrow. Continue our information statistics journey. So I'll ping you once again tomorrow, and we'll meet tomorrow. Okay, thank you.
Professor, weekend you are planning to take class. Is it the evening time or daytime?
Evening, no, weekend we will not meet. Tomorrow we'll meet because the weekend I have some other lectures. So it's not for DSU. I have something else.
Okay, fine.
No, because it's a bit spread out and all. It was spread out for this weekend, and because you people had classes and all, that's a thing. In case I may have for Sunday morning, in case all of you are free and all. So I'll ping you on Saturday if you are free. I'll take it on Sunday morning. Otherwise, we'll tomorrow they will be there. We'll again meet on Monday. Okay.
Okay, fine.
Yeah. Thank you.